Hello everyone and welcome again. This is video number 12 and today we are going to use Python and descriptive statistics. This time we are going to use Python libraries, Numpy, Pandas and Statsmodels. In the previous video we did the same calculations, the same descriptive statistics calculations manually, but with libraries it's much faster. So we are here in Jupyter Notebooks in the free version, but you can already create your account. If you have any doubts, go to video number 9, number 10, I think. And in order to start, we use import the libraries. We are importing Pandas, NumPy, Matplotlib, Statsmodel, and SciPy. You will see later in this video or in the next ones how do we use all of these libraries. So after a few seconds it should finish to execute, and now we need to know which versions we are using. So that's very easy with depending on the variable name that you import the library to, like MPD, MP, PLT, Statsmodels, and then dot version, you will get the version that you are running. So here it's executing. It's taking some time, and now we got it. So from MP, which is NumPy, we have 1.17.3. For matplotlib, we have 2.1.1. For statsmodel 0.8.0, and for scipy 1.1.0. Now we are going to get the dataset. So for this dataset, we are working with height data. So basically people and its height, and that's basically it. Then we are going to get the shape of the data. We already saw that in the previous video. That only shows the number of rows and the number of columns. Okay. Now with the NumPy library, we can get the mean, the median really easy. So mp.mean, we have 169.94. The same for the median, but for the mode, no. So NumPy doesn't have an attribute called mode, but we can use pandas for that. So with our data frame, at the end we have .mean, .median, or .mode, and then we got the same values as we got before. You can see 169.94 and the same. Now let's check with Statsmodel. So we are going to use from Statsmodel the desRstatsw function, and then from that we are going to calculate the mean. So you see 169.94. So we already saw 3 different ways to calculate the mean. What about with SciPy? So from SciPy, import stats, then stats.mode, and then we got the array. 188 is the height which is used the most in the dataset, and it's been used 15 times. Okay. Then we can get the minimum and the maximum with NumPy. That's very easy. We're showing 140, 199. Then we can get the range with the PTP function from NumPy. The range is 59. Then we can get the range in manually, but just with the max height minus the minus height. Now let's go to the percentiles. Using NumPy, we use mp.percentile, the data frame, comma, then the percentile, which can be 25, 50, 75, then interpolation, and then we got the value. or we can use a different way like this, or using Statsmodels as well, and then we get the same result. What I want to show here is that you have 3, 4, 5 different ways to calculate the same numbers. It's up to you to decide what to use. So we get the 75 percentile, and then we have to get the interquartile range. So the interquartile range is only Q3 minus Q1. We can do it with a function EQR, or we can do it manually Q3 minus Q1. Pretty easy, no? What about the variance? So when numpy I.bar and the frame, we can get the variance of the height, which you can see in the screen. And now we can get the standard deviation. We can use the std function from numpy, or from the other library Statsmodel, we can use heightdesc.std, or standard deviation, if you know, is equal to the square root of the variance. So with the sqrt function, and by passing the parameter height.var, then we can get it. And I think we made an error somewhere. Can get it here. Let's go back, and this should work. Yeah, and we got it. My typo. In the next video, we are going to check with SciPI the skewness and other important elements that you should be aware of. So I hope you find this video informative, and see you in the next one.